Mr. Allen here, working on our last tricky task, number 6. Say it's one of our favorite parts of the holidays is the flashing lights that are put up on people's houses. One problem with some of the lights is that if one bulb burns out, all the other lights go out. Make a set of 6 holiday lights of different colors that will stay lit if one burns out. You must have a switch to control them, and you must use a 12-volt battery. I want the 4th light in the circuit to be burned out with the first 3 and the last 2 still lit up. So I'm going to go grab a battery. I'm going to change it to 12 volts right away. Go grab my bulbs. We get 6 of them in a line. I'm not going to hook up all 6 right away because a lot of times when you start experimenting, if you do it on all 6 of them, you might end up blowing all 6 of them. And then you got to waste all that time adding new ones. I'm not going to change the color until the end of it either. So what I'm going to do is I'm going to hook up one bulb. I got a strong feeling the bulb's going to blow. Sure enough, okay, I'm going to turn off the board, add a new bulb. And lately we've figured out that 8.1 has worked out okay. But that was with a 9-volt battery. So we'll see if 8.1 ohms still works with a 12-volt battery. Not quite. So it's got to be higher than that. So we've got to add a bulb. Maybe we go 10. Enter. Still goes off. So grab a light bulb. Let's go 12. Still burns out. Try changing this to 15. Press enter. Turn it on. And it seems to work. So I'm going to go change this one to 15. Enter. This one to 15. Enter. Go change every bulb to 15 ohms for now. Now I'm going to go hook them up in this parallel circuit. All separate loops. One example of a parallel. I'm going to turn it on. Seems to work pretty good. I'm going to remove this wire. I'm going to add a switch because it did say we had to have a switch. That way I can turn this board on. Just turn everything on and off with this one right here. Also going to go change our colors right away. Maybe I throw in a red one. Throw in a green one. Throw in a blue one. Maybe we'll make this guy white. Leave that one yellow. Maybe we'll go with a more of a pinkish color. So I turn the board on. Oops, never change this one to white. I won't let me choose white. I'll choose like a light blue. So, there we have it. Set of holiday lights. We can turn them on and off. Very, very multicolored. But it tells us we need the 4th bulb in the circuit to burn out. So this one right here. We need him to burn out. So I'm going to go click on it. I'm going to lower the resistance so that it does burn out. I'm going to change it to 10. Burns out. But none of these bulbs had their brightness change. None of these bulbs had their power supply cut out so it would turn off. So as long as I build this with a parallel circuit, this bulb will not turn off. If I build it in a big series circuit, this series circuit would be broken and all of the other bulbs would shut off. Okay? So what you need to do is you need to have that 4th bulb lower the ohms. All right, you could get fancy too. You can remove this piece of wire, add in a oscillating power source. All right, well this has gotten complicated, so we had sort of a glitch on our board here. Let me grab this oscillator, try it this time. Yeah, there we go. So instead of having a battery, this is now our power source. I'm going to bump this volts up to 12 volts. All right, and what you can do is they flash. Oscillating means that it's changing the amount of power it's giving them. So it's giving it fluctuations of power, which is making them flash on and off. Well, this frequency is how often they flash. You lower the frequency, they flash slower. You raise the frequency, they flash more often. So if you did want to have that flashing one, like I did mention in the activity, you wouldn't have a battery. You would have a oscillating power source, which is down here, sort of like that. And there's your solution for task number 6.